When we represent the formula for salts and the name for salts, there's a couple of things we want to focus on. Let's first start with the name. Salts always have a compound name, a two-part name. The first part is always named as the cation. The cation always comes first. The second part of the name is the anion. The anion's name always comes second. So what is the name of the cation? It's the element that's lost its electrons. It doesn't matter how many of them there are. It's just simply the name of the element that lost its electrons. It could be sodium, it could be calcium, it could be any metal that tends to lose electrons. The last name, the anion, is always the name, but it's going to have a change to it. The ending of elements gets their name changed, the ending of the name, to IDE. For example, if the anion is oxygen, when it loses its 2 electrons, it becomes oxide. Fluorine becomes fluoride. Chlorine becomes chloride. That's always true for element anions. But sometimes there is something that we know as a polyatomic ion. We'll learn more about those in a bit. The polyatomic ion's name is the name of that polyatomic ion with no changes. For the cation, the only additional part that might be included in the name is a Roman numeral. To determine when you want to use a Roman numeral, we do that to something called a multivalent cation. And the Roman numeral is the oxidation number, the number of electrons lost by a cation, and it's inserted in between the first and last names. Let's look at some examples. For table salt, you know its name is sodium chloride. And as a two-part name, I always say put the cation in a circle and the anion in a box, or put the cat in a bag and the ant in a box. For the next one, Mg, the element's name is magnesium. And the anion is iodine. As an anion, its name will get the ending change. The INE in iodine becomes IDE. And again, I've got first name as the cation and last name as the anion. For our third example, we have the element zinc as our cation and the element bromine as our anion. And bromine, instead of INE, becomes IDE. So we have our cation and our anion.